The exam says, install and configure a CNI of your choice, Flannel or Calico, and then adds one line that makes the choice for you. It must support network policy enforcement. Flannel does not enforce policies, so this is a Calico question. Let's install it from the manifests, verify it, and prove a policy actually blocks traffic. Here's the setup. A fresh cluster has no CNI, so its nodes are not ready, and core DNS is pending. The question offers Flannel or Calico, says install from manifest files, do not use Helm, and lists 3 requirements. The CNI is properly installed and configured. Pods can communicate with each other, and it supports network policy enforcement. That last requirement is the trap. Flannel gives you pod networking, but silently ignores network policy objects. Calico's manifest install is operator-based and comes in 3 parts. First, the operator CRDs, then the Tigera operator itself, a deployment that knows how to install and manage Calico. Then you hand the operator an installation resource describing the Calico you want, and it deploys everything into the Calico system namespace to match. 2 things to know before you touch the keyboard. The installation's ipPool CIDR must agree with the cluster's pod CIDR, which is 192.168.0.0.0.16 here. And these manifests need kubectl create, not apply. The CRD file is bigger than the annotation kubectl apply attaches, so apply fails on it. Start by confirming the starting state. Every node is not ready, the classic symptom of a missing CNI. And listing pods across all namespaces shows 2 things. Core DNS is pending because there is no pod network for it to join. And there are no Calico or Flannel pods anywhere, so no CNI is installed yet. This is a fresh cluster, and the network plugin is ours to install. Install the operator pieces with kubectl create. The first file registers the custom resource definitions, 32 of them. The second deploys the Tigera operator itself. Note the verb, create, not apply. Some of these CRDs are larger than the last applied annotation kubectl apply wants to attach, so apply fails on this file, and the Calico docs say create for exactly that reason. A few seconds later, the operator pod is running in the Tigera operator namespace, waiting for us to tell it what to install. Now describe the Calico you want. This installation resource is the heart of the stock custom resources file, and the field that matters is the ipPool CIDR 192.168.0.0/16, matching this cluster's pod CIDR. If those 2 disagree, you get the same class of pain as a Flannel CIDR mismatch, so always check before you create it. Create it and the operator takes over, pulling Calico up piece by piece. The tigerastatus resource is your progress bar. When every row reports available true, the install is done. Trust, but verify. In Calico system, there is a Calico node pod on every node. That is the data plane that wires up pods and enforces policy, plus Typha and the kube controllers, all running. And the payoff, both nodes have flipped to ready, and core DNS is finally scheduled. The CNI is properly installed and configured, which was requirement 1. Requirement 2. Pods must communicate with each other. Create 2 test pods pinned to different nodes and list them wide. Each gets an IP from 192.168.0.0 on a different host. Then exec into test 1 and ping test 2's pod IP. Replies come back across the nodes, so pod-to-pod networking works end-to-end. One practical note, ping the IP, not the pod name. Bare pods do not get DNS records, so a name lookup fails with bad address, even on a perfectly healthy network. Requirement 3 is the one Flannel cannot do, network policy enforcement. This default deny policy comes straight from the Kubernetes docs. The empty pod selector selects every pod in the default namespace, and listing both ingress and egress with no rules denies all traffic in both directions. Apply it, confirm it exists, and run the exact same ping again. 3 packets, 0 replies, 100% loss. The policy is not just stored in the API, Calico is enforcing it on the wire. That failing ping is the proof the question asks for. A few traps. When a question says the CNI must support network policy enforcement, that one phrase eliminates flannel. Pick Calico and move on. Use kubectl create for the Calico operator manifests, because apply chokes on the big CRD file.
Check that the installation's ipPool CIDR matches the cluster pod CIDR before you create it. Then watch kubectl get tigerastatus until everything is available.
And verification means behavior, not status. Prove the ping works, then prove a default deny breaks the same ping. To recap, no CNI means not ready nodes, and the policy enforcement requirement makes this a Calico question. Create the operator CRDs, the Tigera operator, and an installation whose ipPool matches the cluster CIDR. Then wait for tigerastatus to go available and the nodes to go ready. Prove pods can talk with a cross-node ping, then apply a default deny network policy and prove the same ping now fails. Subscribe, and the full write-up is on dev.to.